Hi folks, we're going to take a look at number 14 from page 469. So 3 parts here. So first it asks us for the value of k that make these two planes parallel, and then the value of k that makes them perpendicular. Okay, then we'll deal with the third question. So again, remember that the angle between two planes is the same as the angle between the two normal vectors. Okay, so in both of these scenarios we should be able to solve the problem just by using the normal vectors. So the normal vector from plane 1 is given by 4k negative 2, just the a, b, and c values. And then the normal vector for the second one, again, a, b, c, so 2, 4, negative 1. Okay, so if we consider a, what do we need to show that two vectors are parallel? We just need to show that they're scalar multiples of each other. Okay, so taking a look at the x components and the z components, we see that that scalar multiple is going to be equal to 2. Okay, so we need n1 to be able to be written as 2 times n2. Okay, and so that means that k, which is the b value in the first normal vector, has to be 2 times equal to 2 times the b value in the second vector, which is 4, and so k has to be equal to 8. Okay, so let's move on to part B. So part B, we have to show that these two planes are perpendicular, and that's the same as showing that the normal vectors are perpendicular. And of course, the way we show that two vectors are perpendicular is to show that their dot product is to figure out when their dot product is equal to 0. Okay, so I need n1 dot n2 to be equal to 0. So here, let's take the dot product. So 4 times 2, which is 8. Okay, plus k times 4, so plus 4k, plus negative 2 times negative 1, so plus 2, has to be equal to 0. And solving for k, we've got 8 plus 2 is 10, so bring that to the other side, negative 10, and then divide by 4, and so k has to be equal to negative 5 over 2. Okay, so that's the value that's going to make them perpendicular. Okay, let's take a look now on that last part, which asks if these two planes can ever be coincident. Well, here we already know that in order for them to be parallel, we need n1 to be equal to 2 times n2. Okay, so in order for them to actually be coincident, their d values have to also differ by the same constant. Okay, so you would need here d1 to be equal to 2 times d2. Okay, but what is d2? So we look at the second. d2 is equal to 4. So we need this to be 2 times 4. So we need it to be equal to 8. But of course, when we look at the d value for plane 1, okay, that's not equal to 1. So this is not equal to d1. Okay, so here, therefore, planes cannot be coincident. Okay, and that's it for this one here.